All right, now that we've created a couple things to dip your toes into AI, let's create a character that will patrol the area, use sight perception to chase you if they see you, and attempt to kill your character if they catch you. So let's go into our AI. Let's make a third folder, and I'm just gonna call this classic, classic horror AI. And we are going to create another character. So let's go to Blueprint class, character, and we will call this AI classic, why not? Let's go ahead and add our mesh and animation like we did with the other ones. So mesh, we'll just add our SK mannequin, bring him down -90, rotate him -90, and use the animation blueprint of just the regular third person and a VP. Okay. Which just has the built-in idle, walking, running, and jumping. All right, so we also want to make this guy a controller so it can run our future behavior tree. So let's right click, blueprint class, search for a controller, and we have AI controller right here. Select, and we will call this AIC for AI controller classic. We don't need to do anything inside of it yet, so we don't need to open it, but I will open my character, go to self right here, AI controller class, we need to change this to AIC classic. So now it is running through this controller. All right, so just like the last one, we need to now create a behavior tree and a blackboard. So let's go right click, artificial intelligence behavior tree, BT classic, just gonna call everything classic. Right click, artificial intelligence blackboard, and this will be BB for blackboard classic. And if we open up our behavior tree, we can choose the blackboard that goes with it. We want the classic, so just select that and save. And we can also switch in between our behavior tree and blackboard like this. But let's go to our blackboard, and we are going to need a key of type vector, and this will be target location. Now, many AI tutorials you may see on YouTube will have your AI wander around randomly in a navigable area until they spot you and then they chase you. I don't really want their path to be random, because that can put them in some weird spots where they're staring at a wall or get stuck on the stairs, and it just looks a little less natural. So instead what I want to do is have them randomly pick a room out of our area to enter, and then spend some time in there, maybe randomly walk around in there. You could take it a step further and choose places specifically in the room you want them to go to and look at. But for this, we'll just be having them go into rooms, spending some time in there wandering around inside the room, and then choosing a different room just as a patrol. So let's go back to our behavior tree, and off of our root, we want a selector immediately. And the first thing we will have the two paths off is if our AI does not see the character and if it does see the character. For now, we'll just work on not seeing the character, so it'll patrol around. So let's create a sequence, and just to remind you, a sequence will go through all the different things in its subpaths in order, and we will call the sequence can not see player. Eventually, we'll add that blackboard decorator that will actually make sure it goes down this path when needed, but for now, we'll just leave it blank and come back to it. And leaving it blank will just also guarantee us that we'll always go down this path as long as we don't add something else to the selector. So we can just test it out like this. So first thing we need is a task for our AI to choose a random room to go into. So we'll create that task, new task, choose BT task blueprint base as an empty class. And if we go back, it creates it in the content browser. So let's create a new folder to hold them called tasks. And we will rename this BT find random room. Let's move it into our tasks and let's save. Now we need a way for the AI to actually select the rooms. So we're going to create an actor for this. right click, blueprint class, actor, and we will call this BP room target. We can open it up. Just so we can have a little visual of what we're looking at, we can add what's called a billboard, and we'll just be able to see this in the editor, but not in the game. You can change what the sprite is. I'll just use a default, I think they have one called target. Yeah, target icon. That's fine. And let's just add some of these in our rooms. So this room here will be one. I won't put ones outside the fences. So let's just drag one here into this room. Let's have this be a room, and let's have this be a room. Change it to unlit so we can actually kind of see in this one because it doesn't have any light. But right now our AI cannot walk through the door. I hit P to show you the navigation.
Hey everyone, Aiden from the future here to apologize. I skipped over a small part in the course where we didn't actually add the nav mesh bounce volume. So you see, if I press P, it shows me this green area, which allows AI to navigate and find where they can walk based on this green area. But if you hit P, it won't be there because we didn't add it. So if I scroll out, I have this big old box selected right here. Not this one, this is the light mask, but this one is the nav mesh bounce volume. So it's actually really simple. I'm just going to delete this one right now, and then all you have to do is search for it in here, nav mesh bounce volume, drag it in, and just make sure it goes over everything you want your AI to be able to walk around in, which for me is the whole stage. So I'm just going to scale it up this way, and then make sure it is scaled up this way as well. And then pressing P will just show you what becomes navigable. All right, back to the past version of me.
The door blocks it because it's a mesh with collision. So for the time being, I'm just going to be removing the door. And as you can see, it creates a path in between, and we'll add it in later. All right, I'm going to hit P again to get rid of the navigation, and we have our three separate rooms. So let's go into BT find random room. And as always, to start off, we have to get an event receive execute AI. So once this task is executed, we want to set our target location, which is the key we made in our Blackboard, to one of these three target room points. What we want to do is set Blackboard value as vector. We need a key. We need to let it know that the key is our target location key. So let's promote this key to a variable, and we will call it target location key, and make sure it's editable so you can set it in our behavior tree. Otherwise it will not show up. And the value is going to be one of those target points. So what we're going to do is get a node called get all actors of class. And the class we want is going to be called room target, BP room target, which is this actor we created right here. Let's actually do that before we set the Blackboard key or Blackboard value. If I can put that in there. So this will get every single actor of this type of our BP room target in the world, which will return 3 different actors in an array, and we want to select one at random. So we will get a copy. So we're going to get one of these actors at an index. Right now they exist at indexes 0, 1, and 2, but we want a random one. So we will get random integer in range, and the min will be 0 and the max will be 2. But in case we want to add more rooms or more target points, we don't want to have to go back in here and change this manually every single time. So to get the max amount of them, we will just drag this off and get the length, which is the amount that there is in the world. But of course the length starts at 1, so right now the length will output a number of 3 when we need this to be 2, so we just have to subtract 1. Put that into max and put the return value into the get, and then this will output one of the 3 room targets, and we just have to get its location, so we will get actor location and put that into the value. And after that, we will finish execute, and we want it to be a success. All right, so let's go back into our behavior tree. Let's actually call that task. So it is find random room. And right here we have this target location key because we set it to editable. And we just want to make sure it's set to the right key. Of course, we only have one right now, but it's a good habit to get into to check. And we do want it to set the target location key, which is great. And then we just want to call one of the built-in tasks called move to. And it needs to know where to move to, which also takes a key, and it wants to be target location. So this task will save this value of the target location as one of the 3 room actors locations, and then we will move to that location. After he moves, it'll repeat to find a random room and then move again. So if we were to play it right now, the AI would not wait a split second before moving to the next one. So let's just add a wait node, which just adds a small delay before he goes to the next one. We can make this 3 seconds. All right, so let's test this out. It is a selector, but of course, since there's no decorator, it'll just automatically choose this one, and it'll play through this sequence. So if we take our AI Classic, and let's just put them up here. Or let's put them in the back room, why not? And when we hit play, or instead of play, we can hit simulate, which means we won't possess our player. We can just watch what's happening in the world, which is kind of nice, and we can watch our AI. And he is not moving, and I know exactly why. It's because we never told our AI to use this behavior tree. And we do that in the controller. So we have AIC Classic, we open it up, event graph, and then in the begin play of this controller, we want to run the behavior tree. So the behavior tree asset is BT Classic, and that is all we have to do. Our AI Classic character already has the AIC Classic as its controller class. So this actor right here will know to use the behavior tree. So let's hit simulate again and see if it works now. So he chose room number 1, and then he will wait 3 seconds and choose another room. Chose this room and goes to that point, waits 3 seconds, and he chooses another room. Chose room number 1 again. So our AI will just do this forever, as long as we live. He seems to have a very heavy dislike for this middle room right here. Let's see if he takes it. Oh, he did. He came around. All right. And that is working very well at the moment. It works, but one thing we notice is he sprints very, very fast, and when he's patrolling, I don't think he should be in a hurry, since he's just walking around and doesn't suspect that anyone is in his precious building. But instead of just going to AI Classic, character movement, and changing a speed here, let's actually create a task for this so that we can change it dynamically inside our behavior tree. So when he doesn't see the player and he's patrolling, we can set it to a slower speed, but then he sees him, we change it to a sprint. So we will go to new task, BT task blueprint base, which is the base one. Go into our content browser and let's rename it BT set speed. Put it into tasks and open it up. As always, event receive execute AI. And we need to set the speed of our AI Classic. So we will get the controlled pawn and we will cast to AI Classic. The controlled pawn will be the object. As AI Classic, we can just get the character movement component, get character movement, and we will set max walk speed as whatever we want. So we will promote the max walk speed to a variable, and we will call this max walk speed, and we will make it editable so that when we call this task, we can adjust this number. After we set that. We want to finish execute as a success. Since we are casting to the AI Classic, in case this fails, which it shouldn't, we can just call a finish execute without a success, off cast failed. Okay, we can also change the max walk speed default to the regular default 600. Doesn't really matter as long as you remember to set it in the behavior tree. And speaking of that, let's go in there now. And when we cannot see the player, before we find a random room, we just want to set our walk speed. So tasks, BT set speed, we'll call this before finding a room. And because we made it editable, we can just choose the speed we want him to turn to. I'm gonna make it something like 225. So slow walk. And then whenever we add chasing the player, we will up it to 600. Now, 225 is a good speed, but the animation blend space we have for the character here isn't quite set up for that. You'll see if I simulate, he's going at 225. You see his feet are very floaty because the animation does not match up the speed very well. So this is kind of an unnecessary step just because, you know, this isn't about animation, but I'm gonna go ahead and fix it because it will definitely irk me. So let's find his animations by going to Content, Mannequin, Animations, and we have our blend space right here, third person idle run 2D. And he's got his 3 states right here. He is idle. Oh, if you want to move the preview value right here, you hold down shift while moving your mouse, and that'll preview the value. And I'm not gonna go into too much about how blend spaces work, but we basically have his idle state, his walking state, and his running state. And these are used at speeds. So if you could see the speed value that changes as I move the preview, this is the, to put it in the simplest terms, this is the animation he plays when he's at this speed. So right now, we set his run speed to 225. So if we move it to 225, this is kind of the animation he's doing, which is kind of wonky. We want it to be this animation. So we have to move this key to 225. We're also, in the future, going to make his sprint speed 450 instead of 375, so we can just adjust that too. So to put that above 375, we'll just go into horizontal axis over here. We're going to change the maximum axis value to, let's say, 500. Now you can see this is set to 500 instead of 375 because it's all the way to the right. And we need a few more grid divisions because if I hold and drag to change these, it snaps to these grids, and there isn't one at 225 yet. So I'm going to change the number of grid divisions to 20 so I can get a value at 225 and at 450. So I'm just going to drag these to 225 and the run speed to 450. Great. So now it should work. So let's test this out. He still moves at 225, but now the animation should be fixed. So you should just be able to do the walk animation. And there we go. It looks much, much better. But as you can see, if it kind of shows up, when he rotates, he kind of just snaps his rotation. We want it to be clean. Let's see if we can see it here. Yeah, see how he just instantly snaps his rotation to turn around instead of that happening over time? That is definitely something we don't want. So if we go to AI Classic right here, just go to self, and we have this Boolean checked called use controller rotation yaw, and we do not want that checked. So we go ahead and uncheck that. And then lastly, in the character movement, we can search for something called orient rotation and movement, and we do want that checked. So now when we hit play, he should rotate towards the way he's moving over time. So you can see he kind of turns like that rather than just snapping his rotation, and it looks a lot more human. Probably look best once he gets down here and then turns around. So let's see what that looks like. All right, yeah, that looks great. Perfect. All right, so before we wrap this up, let's take it a bit of a step further and add a random reachable point in a radius. so that he doesn't always move to this specific spot in each room every single time. We can kind of add this radius, and he'll go to a random spot in that radius rather than just the center, so his location does not become predictable. Okay, so if we go into this actor, BP room target, we can add a sphere collision, and it's kind of small at the moment, you can see it right there. We want to make sure collision is set to overlap all, so it doesn't actually block anything. And we can adjust the radius here, and we're just going to use a sphere collision to determine how far they can, how big the room is, essentially. So I'm going to go into the construction script, get the sphere, and get set radius, set sphere radius. And the radius will be a variable, so promote variable, just call it radius. Update overlaps can be checked, and we want to make sure radius is editable. So now, on each target point here, we can individually adjust the radius for what we want. You can definitely take it a step further and make it a box radius for wider rooms like this, so you can adjust it lengthwise, but essentially you don't have to worry too much about the limits of this sphere. So I'm going to worry about it in lengthwise like this. That looks pretty perfect to me, because we're going to set it up so the AI doesn't try to like walk over here where there isn't even ground, because we'll be using this navigable mesh to let our AI know the boundaries. So let's get this one, and let's drag it out a bit, and something like that is good. Maybe keep him outside the doorway, yeah, something like that's good. And lastly, this one, and something, yeah, maybe something like this. Okay, good enough. Okay, so now if we go to our BT Classic, we have this task, BT Find Random Room. We have to go into that, so you can just double click on it. And instead of setting our Blackboard value as the location of our random actor, we want to switch this up a bit. So let's move these out. And we're going to get a node called get random location in navigable radius. Okay, the origin will be the actor location of our random actor, and then the radius will come from our actor, and we will get the radius variable that we created. So if we go to BP room target, we created this variable called radius. It sets our sphere extent, our sphere radius, and I want to let you know that the sphere here on the actors don't actually do anything for our AI. They're actually just a visual representation for us. You could take the sphere out and just manually set up a float for your radius, but of course that'd be a lot harder to kind of guess how big the radius actually is. So this is just for a visual representation. So we get the radius and we just plug that into radius, and the random location that comes out of that will go into our value. Okay, so now our AI will choose a room to go into every time, but also should choose a random point inside each room. So let's simulate again, and let's see where he goes. So he goes into this room, and it's kind of in the center, kind of where the original point was. Same with this room. But what the node is doing, perfect example right here, is it's choosing a random point inside that spherical radius for the AI to walk to. So now it's not a predictable thing for each, for you to know exactly the location our AI is going to every time he goes into a room. Let's go and check out the gate right here. So like I said, you could take this a step further if you want, just using the exact same technique inside of itself by maybe first choosing a room with a target point and having a second actor be, specific room targets where he could go inside the room and then choose something to go to specifically. And you could put one on the trash can, you could put one on this camera controller here in front of this poster, so that he would choose a room and then randomly choose like one of those three things to go to inside that room, instead of making it totally random. It's totally up to you, but since it's essentially the exact same technique, we won't be doing it in this episode, as it'll just drag on with me showing you the exact same things that we already were just doing. But this is a great start. We have our AI patrolling, and he doesn't do anything else other than patrol, but we will slowly but surely fix that in the upcoming episodes. Alright, thank you for watching. I'll see you in the next one.